Today we will talk about a little different perspective to web services. We have been talking about our PC stuff for the whole talk series. Today I try to have a different point of view to show you that there are very different concepts also being proposed that are very interesting and solve a quite different class of problems. Now, what will I talk about today? I want to start with a little comparison between the two fractions within the XML community, that is the data guys and the document guys. They have so far agreed on common standards, but are about to go their own separate ways, so we'll have different XML standards from the competing groups in the future, likely. I will then go on and highlight some problems with RPC that have been somewhat neglected in the past few talks. And as part of a possible solution, I want to have a closer look at XML, because there's a lot more to XML than has been shown so far. And there are a lot of standards proposed, and it's rather confusing. I will follow that with an overview of some solutions based on the idea of XML as a document. We'll have two approaches there, and I will wrap it up with an assessment whether this different document approach makes any sense or is useful for certain applications or what you should expect and so on. Feel free to ask any questions as soon as you have them, because there will be a few things in this talk which might be new to you. At least they were for me, so feel free to ask. Now, I told you before that there are basically two camps within the XML world. It's the data camp and the document camp. These two camps come from different backgrounds. They have different beliefs and different priorities. I listed a few of them on the slides. And as a consequence of that, they try to influence the XML standards towards their private interests, of course. And so far, so good. They agreed on XML 1.0 and XML schema even, XML style sheet language, but there are a few more XML standards in the pipeline, and that's where we see the main differences today. On the one hand, we have the data guys who basically think that XML is just a transport. They tell you that you can wrap all your data in XML, ship it from one computer to the other, and parse it at the other end, have an API, objects, data structures in the background, and that's about it. They believe that XML is great for data exchange, but not so great for the actual application, while as the document guys believe that XML is the actual action where the interesting stuff happens. They believe that you can express everything in XML, and that's what you do on the server side is just transformations, very simple. In their point of view, they mix the data, the definitions, so the metadata, and the functionality in one big document. They come from a publishing background where you have mixed content, say multimedia, you have binary data, you have annotated text, and so on. And what they want to do is process these documents and transform them to solve their problems. Like the simple example of ordering from a bookstore. The data guys would go and define a set of APIs to order a book and pay and so on, while as the document guys would say, okay, what do we have? You have an order, which is a document. So you send it on the server side, it gets transformed, you extract the address and so on, and you ship back another document, maybe confirmation or a request for payment or whatever. So in the end, it's all documents. And as I have said before, today I want to focus on the document point of view because that's less known than the data point of view. There's a lot of activity going on there. It's more academic than the data point of view, which you're familiar with the common programming languages like Java or Perl, whatever. They are more based in the data world than in the document world. Now, for the next slide. Let's look at some problems with RPC. And we have looked at a lot of XML output through the weeks, and it has always basically come down to the point where you have some kind of API that you program against, that you maybe discover with Whistle or UDDI or something similar. And it's what you all know from object-oriented programming. You have methods, you have parameters, you have return values, you have interfaces, so nothing new there. But as you might have experienced yourself in daily business, that's not really convenient for business guys to understand. They don't usually think in terms of API and interfaces and what kind of methods would fit with your problem. They rather think in terms of entities like customer and orders and stock, stuff like that. And your job as a Wirtschaftsinformatiker is to translate these business requirements to some kind of object and programming model. And that's where often you have slight differences or large differences of opinion. And that's where you have the fight between the business side and the IT side, because these two sides don't talk to each other a lot and they don't understand their respective needs. So why do we still use these APIs, which are very low level? It's really pushing primitive data types around, and why do you still use these after so many years of evolution in the... Yeah, question? No. If you want to get something to drink, you may want to go for it now as long as the guys are still here. Huh? Okay. For those of you who were present when the gentleman from Sun talked about EBXML, EBXML being a project to basically describe the world in XML. You can imagine that with this level of detail you usually have with an API, this does not work very well. You have to reach higher levels of abstraction to deal with the complexity you see in the real world. So that's another argument for doing away with API and manipulating data at the very low levels. And also we have talked about metadata a lot. All these nice ideas what we could do if we only had good metadata available, like semantic web, automatic discovery, and so on. So it's not really easy to fit metadata into a traditional API, because granted you can have parameters to a function, some optional parameters where you could hide the metadata, but it's more of an add-on than an integral solution. So clearly the data point of view is not suited to these kinds of problems. The next problem concerns interfaces. It's quite related. Maybe you had to program against an interface you have not written yourself in the past. You may have experienced some irritations when you found out that the definition of the interface and the actual implementations do not match. You have differences with the data types, you have problems like this, it doesn't match. We discussed these problems in my talk about recent developments. And in addition to that, usually every application has its own interface. It exposes a set of methods and classes and parameters, and expects other applications that want to communicate with that application to know about these interfaces and to take them into account and not change them around, which is rather difficult if you consider that the usual application changes all the time. So what do you do with obsolete interfaces when you don't know how many applications rely on that interface? Do you do versioning for interfaces? A lot of unresolved problems. And furthermore, if you have an application that, say today an interesting application would be an agent scanning several websites to determine the best price of a product you're interested in. You could do this today. You could scan through the HTML and try to parse it for the price. It's very unreliable, and basically you would have to write a special case for each website. So as the number of participants in the network grows, so does the number of interfaces you need to support, and for end-to-end communications, that scales really bad. I talked about interfaces not being as static as we would like. They change all the time, so we can basically not rely on them. So one possible solution for that problem would be to keep the interface really simple, and that will be one solution I will explain later on, the so-called XML acceptor pattern, which has just one method, input and output. You will see about that later. Any questions so far? No? Okay. we will come back to security. We have approached the subject numerous times, different talks. Various scenarios have been proposed, like digital signatures, encryption, authentication, and so on. And while all these solutions are technically nice and solve part of the problem, they are more of an add-on than an integral solution. For instance, they usually protect the whole document from change or from unauthorized access. But what about the individual elements you have within an XML document? Let's say you have a different number of clients and they have different needs for data access, what you would call views in the SQL world, where you want to expose only part of your data model to one client and another part to another client. So what do you do with the traditional security schemas? You cannot do that. You can just wrap the whole XML document, sign it, and hope for the best. So what is needed is access control at the element level, so that you really can determine whether the client has access rights for this particular element. And obviously this comes back to metadata. And you might be aware of that most security violations occur within an organization and not without. It's mostly insider jobs that harm a company and steal data and so on. So how do you protect against people who have intimate knowledge with your application? That's even harder. Now, for something we have not talked about, or only in passing, it's performance. As you can imagine, these XML protocols are not very efficient. If you remember the great calculator examples we had in the last 2 talks, you might remember that it takes a lot of XML to just add 2 and 2. So in terms of network speed and interactivity and latency, XML is not really a good solution. Clearly you can compress the data, but that's beside the point. XML is very chatty. It uses a lot of characters to describe simple data. So if you have an application that, say, checks your stock every second, that really generates a lot of data. And this kind of application is maybe not very well suited for a web service, because it generates a lot of overhead and you have to build all the HTTP requests and parse the XML to just get a tiny bit of data. So web services function a lot better if you have larger requests, because then the transmission and latency problem is only a small part, because you take time to translate the document and process it, and the transport time becomes irrelevant. Whereas if you have small amounts of data in often intervals, it doesn't really work. So this would mean we have to move away from our current way of doing things with the request response type of applications, which you are all familiar with. I think most of you usually program in a local environment where you have different classes talking to each other within the same machine, so you don't encounter these kind of problems. But as soon as one part of the application is remote, the delay you have is several orders of magnitude bigger than if you have the same execution locally. So you have to take that into account. And unfortunately, the most common development platforms do not support this notion very well. Like Visual Studio.net, you correct me if I'm talking. Yeah. Visual Studio.net is very interesting if you have existing classes and you just wrap them with one little label and expose them as a web service. Very easy, very quick, but you have to ask yourself whether it makes any sense to expose a calculator class to the web. So what would be needed is a framework that takes several of these individual little chunks of data together and creates larger documents and sends them in one go and gets back a more complex response, in other words, a document. We will look at one possible solution for that problem, that being tuple spaces. Not sure whether any one of you heard about it. It was rather new for me, but very interesting. Now, talked a lot about problems. Certainly, you have a few more in your head that I left out now. Now, what can be done about these problems? I believe that the document camp actually has a good idea about these problems, because they have traditionally encountered these problems in their daily work when they worked with large documents. They had to solve these issues before. So clearly we can learn something from these guys. And the following slides are quite academical in nature. There's not a lot of implementations yet. A lot of recommendations and specifications, which are mostly still theories and have, in the best case, some alpha implementations. So keep that in mind if you judge it. We'll come back to the merit of these approaches at the end of my talk. The document people basically believe that you can explain everything in XML. So what you need is a powerful way to manipulate XML documents. Maybe you have heard of a few standards in that area, like XSLT, style sheets, or XPath, XQuery, XML schema, and a few more. The main point being that the processing is important. And since there are so many standards to choose from, the question has come up what to do with all these standards. How do they fit together? And I can be very frank with you, this question has not been resolved completely yet. So as far as I know, nobody knows how these nobody has figured out how the big picture for XML actually looks like. There are about 10 different XML standards, at least the more common ones. Of course, there are dozens more. But what is needed is an XML processing model, like an agreed-on way to look at the XML stream and process it in one step after the other. And that's what I want to focus on next. I tried to make sense of the various standards in the XML world and tried to see how they fit together and how they solve different parts of the XML problem. And that's what I came up with, this processing pipeline, where you have at the left side basically a stream of characters, like you all know, the white space and the angle brackets and so on. I've even made a little XML example for you. As you move to the right, you have as a first instance a parser who eliminates the white space and does away with the angle brackets and gets at the actual information within the XML document. Then goes on to validate the document if there is an XML schema. This can be rather simple validation or a rather elaborate validation. It really depends on the XML schema. It might perform some calculation to verify that the XML document is valid, well-formed, syntax, everything. Even some semantical aspects can be checked if you have a really good schema. And the output of the XML schema engine is something that's called the post-validation info set. Now, what this basically means is an internal representation in the memory of the computer. I here showed it as a class. So you basically take the XML and build a data structure from it so that you can work with it later. That might be a class or a tree, an array, hash, whatever fits your data. Traditionally, you have different ways to access this data model, like DOM or SAX. A few of you might have heard about it. And now it gets interesting. On the right hand, you are free of tags and white space and all this stuff that does no longer matter, and you have just the data and its meaning with the schema. Now the document guys proclaim that XML contains all the information needed. So as they say, it's just a matter of transforming the incoming XML document to an output. And for that, they have created different transformation languages. Of these, the XSLT is the most popular. I will show a little example of that afterwards. And what you also want to do is get at the actual data within your data model. So you have ways to query the data and get a subset of it and do some further calculations. And the transformations are actually quite similar in their concept to Unix pipes. I suppose you're familiar with Unix pipes, and someone's not familiar with them. Shall I explain them? Yeah, the definition is on the slide. Okay. It's a very simple concept. You have incoming data, you do something with it, and pass it on to the next step. Example from the Unix world. You have a command to list the contents of a directory. It generates a character stream. This character stream is piped. That's supposed to be a pipe to WC. That's not a toilet, but word count. So this simple example just counts the number of paragraphs and words and sentences within that character stream. Now that's of course a very simple example, but you can imagine having another pipe here, and so on, and so on, and so on. And if you move from left to right, you can have quite complicated transformation with this very simple concept. Now, you have the same thing on the XML side. This is an XSL style sheet. That's like a template that tells you what to do with the incoming XML, how to process it, and generate the output. In this example, it's a silly example, but a really useful example would not have fit within this space. This example transforms the input tag E1 to the output tag E2. It's rather verbose, as I said before, but the main point is, while you have here a stream of characters and you basically know nothing about the content, here you have a well-formed, syntax-checked, validated XML data model. So you have a lot of more metadata available, and you can take that into account in your transformations. So that's where the comparison actually breaks down, because these transformations are a lot more powerful because they have potentially much more knowledge about the data being passed to them than the traditional Unix pipes. So that's really the core argument of the document guys. They say all problems can basically be reduced to a number of transformations like these. So if you want to program with the document point of view, you basically have to learn how to process input into output using, for instance, this XML style sheet language. Yeah. Anyway, I want to focus on queries next. That is, if you have no questions. Well, here it gets a little bit more complicated still, because accessing the data is really a point of divergence between the data point of view and the document point of view. The one side you have the guys coming from the database world with their main language SQL. On the other hand, you have the document guys who are used to work with data that is not very structured. Your typical document may contain an unknown number or mix of pictures, text, and references, and so on. Whereas we try to have strict data definitions in the data world. You have a third normal form. You have all these checks, and these two camps have different priorities. You are certainly familiar with the priorities of the data guys, because that's what's mainly been taught at the university. On the other hand, you have the priorities of the document guys. And there you find things like full text search, which is not so trivial. Maybe you're familiar with research in that area. It's really a difficult problem. You have documents where you know nothing about the structure, or almost nothing, because it can be in any kind of structure, and you still want to be able to access and modify this data in an efficient manner. And obviously, you cannot base your work on assumptions that you could in the data world, because it's just unknown what you have in the actual data. Now, coming from these different backgrounds, different standards or different proposals were made. On the one hand, the already shown style sheet language, which has elements to locate elements. Of course, needs that. Before we had the example with the E1 being transferred to E2, so there must be some way to identify all tags with the label E1, and therefore the style sheet language has means to access the content of an XML document. The data guys proposed the XQuery standard, which is more based on an SQL-like syntax. As far as I know, it even has some algebra beneath it, and it's a lot more formalized. Now, there are all the time these XML conferences, and these two camps still talk to each other, fortunately. And the guys basically agreed to try to find a consensus in the query area, and what they came up with is the XPath 2.0 standard that's currently being drafted and should be a final recommendation within a year or so. So it's all very recent work. Now, I'd like to emphasize a little bit on the XML query standard, XPath to be precise. I found a nice example in a lecture from the ETH. And what you have here is basically some sort of tree structure, some XML data fragment, and you now want to access subset of that data. And I listed 3 very simple examples to give you an idea what you can do with this XPath language. The first one, I guess anybody know what it does or has any idea? Maybe Benjamin knows. Maybe not.
I know. I suppose it's some kind of function written in XPath. Am I right over there?
Yes.
Well, I didn't even get an ISP point for that, but anyway. And you have some kind of constructor which you are referencing. I'm right so far?
Yes, you're speaking very general terms, so yes.
Experts will have all these two things. I had about 30 minutes to study this stuff. So the function defines itself in the acceptor pattern, which is a function which is author can define in itself this thing called a constructor, which in itself can be a function as well to access data in the tree. So actually, this is what we are looking at.
I didn't follow you completely, but the point you make is true. It can be very complex, the expression. However, this is supposed to be a simple example, and what it does is to get the element where to get the author element where the first name is Benjamin. So this first query would result in this part of the tree being returned. Now as to the second example, this actually looks for the ID. Maybe you're familiar with the concept of ID. Besides having these tags and so on, usually you have IDs to describe nodes within your XML tree specifically. So this book 2/price would select the book tree with ID 2 and the price. So this. While as the last example would actually do some comparison. It looks for all books with price below 9. And then you can have regular expressions. A very powerful way to select data. Here what you have is actually, because I'm not too sure about the finer points of this, but basically what it does is it looks for the price and then goes up the tree towards the parent and selects the whole, goes here and then selects the title. Because before we had examples where you basically select something downwards, not upwards, the tree. So this is an example that you can also go up and down the tree. Now, you're familiar with walking a tree, so I think you can imagine that this can get quite complex. You could have partial trees like this part and this part. Really depends on the query. The point being that these path expressions are very powerful and very flexible and allow you to basically have any subsets of the start XML data structure.
I would just like to clarify something. So I really can have an XML document and do transformations on it, not really relying on the underlying path structure. So I do coding on the tree, basically using graphical elements. Well, using graphical structure to do my coding on it.
Yes, the XPath has, of course, knowledge of the XML schema, so it can validate all expressions, whether they make any sense. If you query for non-existing tag within your structure, the query will fail right at the start. So because this processed XML has richer metadata available than your ordinary character stream, which is basically without any metadata, you can also have more powerful queries. And the next slide will talk about a possible solution for the kinds of problems I explained before by relying heavily on these XML queries. And the concept is actually a design pattern. It's called the XML acceptor pattern. It's very, very simple. It has exactly one method. Accept. You give it a string, and the output of the method is also a string. Can't get any simpler than that. So the interface definition of this pattern is basically this line, and this will not change anytime soon. So first problem we encountered was the always changing interfaces. Well, here you have such a generic interface that it does not change. Okay, so the problem must be somewhere else. Actually it is, but we'll come to that later. There's this one guy who runs a website called xmleverywhere.com, and clearly he's on the document side if he names his website like that. And he proposed this solution back in 1999 when the term web services was not even invented or very early. And I wrote to the author and asked about whether he had any implementation experience with that pattern. And both his reply and some comments on his website include a few interesting remarks about this solution. What you have is you basically give this pattern one document, and it gives you back another document. So we have this kind of coarse-grained RPC we talked about before, not thousands of little exchanges between client and server, but rather one large. And the data that is being passed in and passed out can be arbitrarily complex, of course. So the actual complexity is therefore handled by the XML engine, so the schema and the transformation and the query I showed before. Whereas the interface between two endpoints remains really simple. Now this has some performance advantages. I already pointed them out. And the author of the pattern goes on to argue that this has also advantages for working with business guys to define what has to go on within what is traditionally called business logic. Because XML is it's where the action is. You go and define all your components, your parameters and your stuff within the XML document. And they don't take the form of interfaces and method calls, but rather as a complex XML document, which may look like an order form or something. And apparently it's easier for the average business person to understand an XML document which can contain real-world terms like order and order number and address and stuff, and define the business problem in terms of this XML document, and therefore makes it easier to work together, both from the business and the IT side, and hopefully leads to better implementations. That's according to the author. Now, he claims that he actually had tremendous success with this simple approach, that he was able to do away with a lot of the complexity, or more precisely move the complexity in an area where it is easier to handle. He wrote to me that everything is done at the DOM level. DOM standing for Document Object Model, another term for this parsed XML tree, validated tree that we have seen before. He had never to change the interface. Guess why that is? He also goes on to say that RPC is basically very old school, and that it, in his point of view, just fortifies the traditional point of view that you have APIs at both sides of the connection that listen, and whether you transform or transport the data in a binary format or in a nice verbose XML format does not matter very much. It does not change the fundamentals we talked about. Now, I think this very interesting approach, maybe a little bit too simple, but on the other hand, it seems to work for a large number of problems. So maybe one day you want to implement this pattern. Also, take note that can be implemented very simply as a web service. You can have such a method signature with a web service, so you could implement this with a web service, and it gives you the additional advantage that the web service infrastructure takes care of all the details like transport and encoding and validation and so on. Yeah.
Can you automate the binding of the document to the actual Java objects? Used to do that, or was he using just XSLT for the transformation?
Well, he was not very specific about his actual implementation, but there are actual tools to map the object model to XML, because that's what the data guys do all the time. They serialize their objects, send it through the wire, and at the other end of the wire they make objects out of it again. So yes, this can be done, but that would be more of a data approach than a document approach. I know the concept is very confusing, and I can be quite honest, I'm not so sure about all the details, but maybe the next example will clarify this somewhat more. Any other questions? Did I miss anything so far? He's my backup. He actually has the Google search engine open and looks up all the terms I screw up.
Concerning your question, as far as I understand it, you do not need to map it to any object you have in your program, because everything you do is directly on the DOM. So what you probably want to do is using some accessing language like XPath, do your coding directly on the DOM, and what you get back is your straight result.
Yes.
I couldn't be wrong,
yes.
but...
No, that's true. I missed that one. The XML engine actually produces the object already for you. What you get back is the data structure to work with. You can traverse it with the methods shown. There are others. So you don't need to worry about converting the XML byte stream to object. Of course, that leaves out the questions where the functionality resides, but let's just assume it's just transformations, as these guys do. It's a wild claim, so we'll have to see how it holds out in the real world, because so far it's more of an academical exercise. Okay, I would like to move on to another interesting concept, being tuple spaces. Not sure if anyone heard about these before. At least I didn't. Tuple spaces are actually already about 20 years old. They were invented by a guy named David Gelernter, a quite well-known computer scientist. He developed the concept of tuple spaces back in the 80s, and this picture hopefully succeeds in explaining what a tuple space is. Imagine some space that can be any storage somewhere on the network, a website, an FTP server, an LDAP directory, an IMAP mail store. You get the idea. So you have this container, and within this container you have little chunks of data, or tuples, as Gelernter calls them. And now the concept is very simple. One application puts a tuple into this container, and sometime later another application goes into the container, looks for a piece of data or a tuple that's being labeled to this application. It's like an address. Maybe you can imagine all these tuples have little labels attached that say what their destination should be. And this application either reads the tuple and leaves it alone, or takes it out of the container. Of course, if it is left alone inside the container, it can be accessed by a third application that may also be interested in this particular tuple. So you're not limited to point-to-point connection. You can have one to n or n to n even. All tuples are only accessed by their label. So it's very simple. You ask the container, give me back the label that matches my query. and that can be one or several tuples. Now, what can you do in terms of operations with these tuples? It's also very simple. You have basically three main operations, that being write, read, and take. I explained them already, what their purpose is. And I went ahead and actually copied a little example for a read case. You first you connect to the tuple space, then you query for a document. In this case, you are interested in all tuples with purple as a value. So you have an XML query here. Here it comes back again, XML query. You get a number of tuples back, and then you can process the result. Take is very similar to read, with the only exception being that the tuple is removed from the container after it's being read. So if you want to have one-to-one communications, you have to implement it with a take. As far as security is concerned, you can encrypt the whole content of the tuple and just leave the label in plain text. Now, you may wonder how this compares to other RPC methods, and that's what this chart is trying to illustrate. As always with the charts, if you go away from the starting point, it's better. So the best is obviously here. In this case, the tuple space. It's supposed to be the best. Now, let's start right at the center. You have the traditional procedure call. It's local, within a process mainly. It's normally blocking. That means that the caller waits for the completion of the call to resume operations, and it's synchronous. Now you can have variants of that. You can have asynchronous procedures, like for input-output operations, which are several magnitudes slower. You could have communications between processes, inter-process communications. As you move on this vector, you can be on the same machine or increasingly move out to the network, and as you move here, the latency increases and you arrive at the traditional RPC remote procedure call, about which we talked in detail for the last few talks. Now, to make it short, this kind of remote communications is often called a message queuing system. It's like a SMTP where the sender and the receiver do not have to be present at the same time and can communicate asynchronously, and the message is stored in a third location as long as needed. Now, if you use this concept for web services, you obviously have a few advantages. One being that you can eliminate the blocking call. Usually what you're familiar with is you call something and then you wait and wait, and sometime later you get the result back. On the internet, that can take from milliseconds to minutes. So in terms of time, if you calculate it, that's a large range. So if you can store your actual message somewhere, then you can do something else in the meantime. It's very simple. Just put it, you only have to concern yourself how you get your message inside this container. You do not care about the other side, whether what particular access method it uses to access the container and so on, whether it has connectivity and so on. You can have, in addition to point-to-point, you can also have end-to-end communication, one-to-end communications. This system scales better in certain aspects, especially if you move towards the multi-party communications part, where you have end-to-end communications. It's easier to scale if you do not block. So stateless is better than stateful for scalability. Also, it's more fault tolerant because the connection between the container and the two or more sides of the applications does not have to be up all the time. There can be intermittent outages, it does not matter. So these tuple spaces have a lot of advantages, yet they are still mainly an academic exercise. At least they're not very widely known because they involve a different mindset. It's actually arguably more difficult to program asynchronously, where a result for something you initiated may come at any time. So you have to take care of that, and it's not that easy, and that may be the reason why it's not so common. But it would be very nice if it would be adopted more often. Now, I won't bore you any longer, only a few more minutes, so bear with me. So, I talked about that. Comparing tuple spaces and traditional RPC-style web services has a lot of advantages for the tuple spaces approach. I talked about them already, and the main drawback of this concept is really the concept itself, because it's not well known, and that hinders its acceptance and tool support, and therefore it's while it's a very nice concept, it's unlikely to catch on as long as it's not built into, say, Visual Studio.net. Because if you cannot generate it with a common tool, people are not going to use it, even if it offers substantial benefits down the road. So in summing up, we have seen the two sides of the coin, the data point of view, the document point of view, and I told you already that within the XML community there are increasingly differences between these two camps, and a lot of different Yeah, these different opinions manifest themselves in different recommendations, different standards that actually tackle the same class of problems from different angles. So in the future we will likely see a divergence of these two camps as they go their own ways and try to find out what's really important for them. And as in a relationship, they may learn that they actually need each other in the future. So here's to hope that at some point in the future they will converge again to a common set of standards. However, that's really unlikely before the broader adoption of metadata standards, because that's the main issue of contention where these two camps currently clash. So all this work in topic maps and RDF and semantic web activities may resolve this twist at one point in the future. And on the other hand, there are voices that actually view these metadata guys as a third camp, so you never know. So what do we do with all this information? If you want to develop a traditional web application, a shopping cart system, go with the tools you know, use the data approach that you have well heard about before in all the talks so far. If, on the other hand, you really want to explore something different, want to play with advanced concepts that do not yet relate to concrete business problems like knowledge management, more on the semantical area, or I call it academically challenging or interesting problems, then it may be a good idea to actually take a closer look at these document ideas I talked about in my talk. Now, if there are no questions at the end, that would be about it. Yeah.
And what is exactly the difference between an XML tuple space and, for example, Java spaces?
Not that much.
Query language or?
Yeah, so the concept of, that's a good point actually. I forgot to mention that the concept of tuple spaces was implemented in Java and other languages. Originally, it even had its own language, Linda. I never heard of that, but there are also some other implementations. So it's basically the same concept, and the use of XML may provide further benefits. But apart from that, it's the same concept.
What are the further benefits?
I imagine they could reside within the realm of metadata, because XML really can keep all the data together and have it in an easy to parse and interpretable way, and the schema definition may make it easier to work with semantically rich data. But I'm out on a limb here because I have not really studied that subject too much. But Ben may want to add something.
Since I'm a Google boy, so I went to Google and looked for that. Actually, as I understood in the 30 seconds I looked at the document, the difference between the tuple space we explained here is we really do not need objects. Java spaces do transform the tuples to objects. So this is a fundamental difference because we're really away from the object thing. The objects we have there.
But I guess it's also somehow the idea to transform between XML and the object view. That's also the idea behind the DOM, for example. So
yeah, that's DOM, but the DOM is behind all the stuff.
Yeah, that's if you assume that the object and XML are two separate things, while the document guys really insist that it's the same thing and XML is where the action is. So I think all of our mindsets are biased towards the data model because that's what we grew up with, and it's really hard to to imagine a world without business logic, or with the business logic somehow contained within the document itself, whatever that means. So, as I said before, it's an interesting field, but it's not so easy to approach, and I hope I could give you a little introduction to the field.